Welcome to today's Explainer. We're diving straight into some seriously groundbreaking research from Varsha Shah. She's an enterprise technical architect at TCS and Microsoft, and we're talking about the future of enterprise compliance. Now, when I first heard about this, I kind of thought, okay, they're just throwing more algorithms at a problem, but actually, scratch that, it's way bigger. This completely rewires how we look at enterprise data to spot financial fraud and handle regulatory risks. Okay, let's dive into this and see exactly how it works. But to really get this solution, we got to understand the problem first. So how exactly does super sophisticated financial fraud manage to hide right under the noses of huge, well-funded compliance teams? Well, think of it like a giant jigsaw puzzle. Modern fraud almost never looks like a glaring error on just one single puzzle piece. If you pick up one piece, it looks perfectly fine. The anomaly, the actual fraud, only shows up when you try to snap that piece together with 5 other pieces, and suddenly you realize, wait, this picture just doesn't match. And that brings us to the core conflict here. Traditionally, compliance operates in these total silos. A payroll register, it's checked purely against payroll rules. Vendor invoices, checked strictly against procurement policies. Tax filings, only looked at under tax regulations. It's just evaluating documents entirely on their own. But the modern reality? Fraud actively exploits those blank spaces between the systems. The sophisticated bad actors, they know that if they spread the inconsistencies out across multiple isolated systems, traditional checks are literally never going to catch them. This dynamic perfectly captures the blind spot. If you check a payroll record, a tax filing, or a procurement invoice individually, they all pass. Honestly, everything looks great. But cross-reference those exact same documents against each other, and boom, they fail. A payroll record might look totally accurate. A vendor invoice seems completely legit. But when you connect them, you might suddenly realize an employee is secretly the vendor, which is a massive compliance risk. The information to catch the fraud is actually already sitting right there in the system. It just wasn't connected. Varsha Shah's research hits the nail on the head, calling this exact problem the compliance gap. It's the fundamental limitation of traditional rule-based document-level systems. You see, they're expertly built to validate a single, isolated record, but they are completely blind to the relationships across different documents. And bridging this gap, that is the exact focus of the research we're unpacking today. So, to solve a problem this deeply complex, a single magic bullet algorithm just isn't going to cut it. We need a real paradigm shift. Shah's research proposes a 3-part framework. We've got an entity correlation engine, a probabilistic risk model, and a cross-jurisdictional normalization layer. Put them all together, and they transform raw, isolated enterprise data into incredibly actionable compliance intelligence. The whole overarching goal here is what they call cross-document intelligence. Basically, we're shifting entirely away from reactive, isolated checking and moving toward an interconnected understanding to uncover those hidden, systemic risks. Okay, let's break down how it actually pulls this off, starting with component 1, the graph-based entity correlation engine. This right here is the foundation. Its entire job is to ingest data from all those isolated systems we talked about, payroll, tax, procurement, and start connecting the entities. It links employees to vendors, maps accounts to transactions, and ties the whole shebang to regulatory files. It basically builds a massive, unified network of enterprise activity. By building out that network, this first component essentially answers one absolutely crucial question: what is connected? It acts as the relational bedrock for everything else that follows. It reveals structural anomalies that are literally invisible when you only look at one document at a time. It's drawing the lines between all those puzzle pieces. Now, once we have all these newly discovered relationships, we run into a brand new problem, right? Figuring out which ones actually matter. Enter component 2, the adaptive probabilistic risk model. So instead of relying on rigid, static rules that get outdated almost instantly, this model calculates a confidence-based risk score. It looks at multiple indicators all at once, things like how strong the anomaly is, the reliability of the source, and historical patterns. And by doing this, it answers our second major question: what is most likely to be a genuine compliance risk? Now, what I found really fascinating about this part is how directly it addresses a massive real-world human problem. Compliance teams are constantly drowning in false alarms, but this probabilistic model, it prioritizes the cases that require immediate, urgent attention. It cuts right through the noise, significantly reducing the time folks waste on unnecessary investigations. And finally, we have component 3, the cross-jurisdictional normalization layer. Look, Global enterprises are, frankly, just messy. They operate across different countries, deal with totally different currencies, face varying tax structures, and have to adhere to wildly chaotic reporting standards. This third layer harmonizes all of that financial data. It standardizes the currencies, aligns the tax rules, and basically maps all those local classification schemes into one universal language. Which answers our final key question: how should the risk be interpreted within the appropriate local context? Because without this normalization, a perfectly normal transaction in one country might trigger a huge false alarm in another, just because the formatting or the currency happens to be different. This ensures that the exact same transaction is evaluated fairly and consistently, no matter where in the world it started. Now, a theoretical framework is all well and good, but does it actually work in the real world? Well, to find out, this architecture was put through a massive stress test. The evaluation environment didn't just use a few sample files. No, it processed roughly 3 million real financial records. That data was collected over a 5-year period and spanned 4 distinct regulatory jurisdictions. So this wasn't just some pristine lab experiment. It was tested against the incredible, messy complexity of realistic enterprise conditions. And guys, the results are incredibly compelling. Let's look at the detection performance for a second. The framework achieved an astonishing 91% precision rate. That means when this system raised a red flag and said, hey, look at this, the vast majority of those flagged cases were confirmed as genuine real-world anomalies. It also hit an 87% recall rate, which gives it an overall F1 score of 0.89. In practical terms, it means it casts a wide enough net to catch true fraud while keeping missed detections to an absolute minimum. But what does this actually mean for the humans doing the work on the ground? A 76% reduction in false positives. In traditional compliance, investigators spend a massive chunk of their week just chasing ghosts, reviewing cases that ultimately turn out to be completely legitimate. This system practically eliminates 3/4 of that wasted effort, which directly leads us to our final major metric, a 40% reduction in manual audit effort. Because the system is doing the heavy lifting of cross-referencing all these documents and scoring the risks, human compliance teams can stop routing routine documents. They can finally focus their hard-earned expertise exclusively on the high-risk, complex investigations. But honestly, the real magic here is longevity. Legacy systems use static rules that become totally obsolete the second a new fraud tactic drops. But this AI framework, it continuously learns. Every confirmed fraud strengthens the detection pattern. Every false positive refines the risk score. It adapts on its own, making every single audit even more efficient than the last one. Of course, bridging the gap from research to reality does take a few practical steps. Successful enterprise adoption requires seamless integration into existing ERP systems, local configurations for regional laws, and, perhaps most importantly, human alignment, so investigators can actually prioritize those risk-scored cases easily. And naturally, it demands serious scalability to process millions of records daily, which, as we saw, the evaluation already proved it can totally handle. We'll wrap up this explainer with a really powerful thought from Varsha Shah's presentation. She notes that by fully embracing cross-document intelligence and continuous learning, instead of asking what went wrong, organizations can begin asking what is likely to go wrong next. It's the ultimate evolution, right? Moving from reactive, backward-looking validation to proactive, predictive governance. So as you look at the systems operating in your own industry today, are you just waiting around to find out what went wrong? Or are you ready to predict what happens next? Thanks for joining me for this explainer, and keep learning.